How's everyone's day going?
Where's the Zoom?
If you go into the event on the, oh, I guess you don't have the Discord. Well, actually, you have access to the Discord, right, Mosh?
Yeah.
Check at the top.
How's everyone's day?
Yeah. All right, hold on. So where are you at? I've been signed out. That's not right. There we go.
Recording in progress.
Yeah. Oh, shit. Wait. Oh, there we go.
You know what that gives a lecture on?
What?
Or
Yeah.
those are the phone.
I got time. Nowhere on my You've probably heard it somewhere. Wait a second.
Hang on. Okay, I'm in.
Perfect.
Recording in progress.
Mosh, remember to mute your stuff.
Yeah.
Why? What is causing echo?
I showed them how to show you.
What is causing that? Mosh, mute yourself.
Sorry.
It's muted.
Thank you.
Muted on my end.
Wait.
No, that should be. No, Mosh, your output audio.
Output audio?
Yes. Why are you snapping in my ear? Go sit down.
Yeah, I left computer audio.
What?
The one that Travis.
Yeah, I'm going to be showing that.
Yeah?
Yeah, I'm going to be showing Colab. No, I have Colab loaded.
Okay, I left the meeting.
All right, cool.
It's recorded. Okay, there you go.
Yeah.
But you
I know what I'm
don't know Canvas.
What?
How will you be teaching?
I'm just going to show it as an example of different ways that you can use Python. It's not necessarily going to be like, I'm not going to show off the notebook because we've already done that. I can probably go up to plus 12. That should be enough. Hopefully. Okay. Hisham, can you go sit down in front of me real quick? I want to see if this works. Also, why do you keep coming up? Go away. No one likes you. Okay. Hashem, talk to me.
Yes, testing.
Okay, perfect. The audio works. I'm gonna take out
Could
my
you
headset.
explain what Python is dynamic language?
What?
Could you explain why Python is a dynamic language?
Why it's a dynamic language? Because
I'm giving you a test.
Who's in the DS Science Club, by the way?
The gentleman behind
most
me.
people here.
You aren't in this club.
Did you already join in? Cool. I still need to access the members at some point. One of these days.
I just haven't thought of joining yet.
Feel free to join.
What days are you meeting though?
I told you, right now at 3.
Friday at
I'm
3.
Jonathan Sweet.
Yeah. All right. Well, I'm going to take this out. Hey, Michael.
Shannon's trying to get in.
She's still trying to get in.
Yeah.
Well, I have a lot of people in.
Okay, never mind. No.
The Zoom is existing. Oh, wow. I see what Travis meant by the echo.
She said she's alone.
She's alone? What Zoom did she go to?
Can you see anyone?
The one that I posted in right now? Also, go away. You. Go away.
Never mind.
She found it? Hello, Professor Fitz. The most scuffed Python presentation we'll ever have. Probably the only Python presentation we'll ever have.
What? Scuff?
Scuffed, yes. Yes.
It's gonna be good. I have high hopes.
Okay. Actually,
Good day, Professor. Good.
join us. It was very beautiful.
It looks, okay. I mean, I tried.
I love this thing. It costs like 10,000 per device. It was 8 million for the entire school. And I know we're like the IT specification says not to play with it, but like look at all the cool things I can do. Like, why would I not play with it? Like, I can show the entire room when you're giving like a notification for the data science club. Either way, I actually use the restroom real quick, so I'm going to go do that. I'm going to turn off my mic, and we'll start right when I come back. I'm just going to wait for more people.
As you said, Elijah, about yourself. Alive, without the weather.
Gotcha. Sure, I just have a question on,
That's right. I'm questioning my life.
question 6, or you don't like CS or something?
Oh, no. Well, they don't teach energies.
Kind of, yeah.
This was what bothered me.
The fit values.
Yeah, well, it's a lot of,
So if you got your.
how did I say it? It's not testing your ability to learn, it's testing your ability to, or understand, it's testing your ability to
Okay, so you
get
have
information, I guess.
So
You know,
your fit values are.
What a useful
Predict.
skill.
It's, I mean, to be, I'm not an educator, so I can't say what the alternatives are, you know? But, I was just talking with Larry about that. I have a friend who is an educator. And it's sort of a systematic problem where it's like, how do you create a system?
Like this.
They test you on what's your weak point.
So you can.
Yes.
do
Yes,
residuals.
but I would say that, like with language.
Okay.
There's a conversational aspect. And then there's like-
Let me put this back on. Do I have a microphone? I do have a microphone. Let's go.
Knowing these words as opposed to knowing.
Hello, everyone in the Zoom chat. Welcome. All right, let's. Which is the absolute function. See this? It makes it easier for me to be seen at night when I walk home. That's the reason I'm going to go with. All right. So, Python, what is it? It is a dynamic programming language. It is interpreted, and it allows us to do very, very dumb things and get away with it. And I love it. So, what do I mean by that? Well, not that. Oh, whoops. I forgot to clear this. Hold on. Whoops. Don't look at the man behind the curtain. He's not who you're looking for. All right, let's try that again. Now, what do I mean by this? I mean, we can have any variable be any type at any time. So someone give me a variable name. X. Okay, we're going to assign x pi, 3.14. Very simple. If we recall x, whoops, capital X, we get 3.14. But what if we don't want x as a float point? We can simply convert it to an int. We call it again, it's now just 3. We can do this with any type in Python, with any other type in Python. Take it from one version and convert it to another. And this is very powerful because it allows us to manipulate data in ways that Anyone experiencing audio issues? No. It allows us to manipulate data in ways that we couldn't do before in languages like C and in MATLAB. 208. See, this is the problem when you only have one person running everything and you have no help. Anyways, I'm split between multiple screens and it's very unforgiving. There's many types in Python. We have our basic integers, we have our basic floats, we have booleans, we have lists.
Something I can jump in on.
Not really. I kind of set up for a one-man show, so.
Can you let me into the meeting on Zoom here? I have it here.
It shouldn't be locked to anyone.
I was able to get it.
Yeah. I'm not sure why I can't get in from my app.
What meeting did you go to? Oh, that's the wrong meeting.
No, I didn't join. I joined it when I left.
Yeah, this one.
It was on my phone.
Okay, cool. Technical issues. Okay, anyways, so you have all your basic variables. You can find it on the Python documentation page, which is right here. Whoops, that's not it. That's it. And it allows you to okay, yeah, that's it. My bad. It allows you to, like I said, this is the most scuffed presentation we'll ever have. I apologize. There's many types in Python. We have our tuples, we have our integers, we have our float points, everything that you'll ever need to actually manipulate and use data. Python also has a lot of cool built-in functions, such as the absolute function, which, as many of you in mathematics know, gives you the absolute value of a number. If it's negative, it gives you the positive version. If it's the positive version, it again gives you the positive version back. This allows you to do a lot of cool mathematics stuff, such as square roots. Furthermore, we have a lot of really nice built-in functions, such as length. Length allows you to take an object, usually an iterator object, pass it into length, and get back the length of the iterator. You can also do funky stuff where you can take it and get the byte size back. But I would advise first calling the binary function, or the bin function, and then calling that in length to get the size of the variable that you're using. Of course, you could also just use size, but you have to import another library before doing that. Something really cool that Python has is that it has the ability to use lists. Now, what makes Python lists different than other languages? In most languages, you have to, let's say our list is A. We're going to have it A, B, and C. If I want to access that C at the end of the list, in most languages, you're going to have to do something like this. The length of A minus 1. That's very long, and it takes a long time to type out. And you don't really have that much time when you're trying to code an assignment 5 minutes before you have to turn it in. Cool thing about Python, you can access indices using negative numbers. Any negative number, access it from the end. So if I type in A minus 1, which if I zoom in a bit, which of course can't zoom in on this one, we get C. Actually, there is a way for me to zoom in. I set this up already. There we go. Close enough. And we're just going to go back to this, which is honestly really cool, and it's really useful for when you want to go through and iterate backwards in lists. Another thing you can do is that you can do what I call segmentation access. Segmentation access allows you to do something like this. So we're going to reassign A to Apple. What's up?
So just to clarify, when you're using like a negative integer to step through like an array,
Mhm.
you start at the other end and then you work back.
Yes, so the thing is, zero is always going to be the first. This is something that is really useful to know. Zero is always the first value, right? There are ways to change it, I don't remember off the top of my head, but the negative number will start off at the last index. So -1 starts at the very last index of the array. So if we take the -1 of apple, that's going to return E. Nope. E. And this is very useful, again, if you want to iterate backwards. There's many algorithms that allow this. It also can be useful in, just regular access. Kind of a cool thing, which again, I'm going to call it the segmentation function. I don't remember the name of it. I tried to find it, and I couldn't find it online. Let's say we want to only access part of this string. Let's say we only want to access L. How do you think you'd do that?
Access what now?
I want to access L.
Like the.
So I don't want to. I want to access everything after A.
Oh,
It's really cool.
like a fourth.
Double dots.
Yeah. So we use the colon.
What's this?
So this allows us to take from any iterator type. So hello, Drew. An iterator type can be a string. An iterator type can be a set. It can be a list. Anything where you can access individual values counts as an iterator type. And this allows you to create subsets. It allows you to only manage very small sets of the list. It's very powerful. And the way it works is that you access, you give it a beginning value. I'm going to do beg. You give it an ending value. If you don't give it any ending value, it's just going to go to the end of the iterator. And then you give it a step. Whoops.
The iterator doesn't start at 0.
It does. You can start at 0. I put 1, right?
Yeah.
So it's going to start at P,
Oh, I didn't.
because that's,
Gotcha.
yeah, index 1. So step. Now let's iterate through Apple real quick. So let's say we want to just get PP, right? Very mature, very college level example. We're going to use the negative value I showed earlier, and we're going to do 1 colon -2. And like that, we have access to PP. Very useful. What's up?
Is this recursion, by the way? It looks
No, this is just access.
It's linear, it's like a linked list in a way.
Yeah.
Iterator. It's just pointing to an element, and that element has basically directions to it, the next following element. So you're not actually creating a full copy of the string or anything when you're doing this. You're just accessing a specific piece of data.
Yes, I am creating effectively a substring. How it actually works in Python, reference object, which we casted out in this case, called, again, we don't have a name for it, and it is between P, the reference point, instead of starting at A, starts at the first P, and then the ending reference point, instead of at the E, it's going to be at the second P, which is really useful because it doesn't waste data. If you want, you can add .copy afterwards, and that will create an entirely new object, which will not manipulate the original iterator. Another very interesting thing in Python, I didn't set up yet. There is a way in the newest version of Python to access a created variable that wasn't set to a value by using underscore. I'm not on the current version of Python, so unfortunately I can't show you. Something to note, Python is not backwards compatible or forwards compatible. Well, it is forwards compatible within a version to an extent. When you're doing Python code, it is very wise to specify what version you coded it on. So in this case, this was coded on 3.11, because if you open up the code in another version of Python, say 2.7 or God forbid 3.18, and it doesn't work, you know which version of Python to roll back to in order to make sure the code runs. A bit of a finicky process, but there is actually a pro to this in the industry. Say if there's a security exploit, it can be patched and everyone can move on. What's up?
How would you update it? Would you just paste the code?
There on the documentation page, it is really well documented about version changes. Your IDE should tell you what part of the code, it'll highlight it in red or depending what your IDE is, and you just go and see what the new version of that is on the Python documentation.
Okay.
Yeah. Yeah, it's really simple, it's really fun. Let's see. That's not what I meant to do. All right. What did I have next? So there's many ways to access Python. You could do it locally on your computer like I'm doing here. You could do it on the cloud, or you can do it on a server. Here at the Data Science Club, we tend to use something called Google Colabs, as seen right here. Google Colabs is a cloud-based version of the Python IDE, and it is in a journal format. Something really cool about Python is that Python allows for journals. If you ever use MATLAB, you might be familiar with this as code segments. And what journal allows you to do is it allows you to break up your code into groups of lines, and you can run each line individually from each other. This is really good for data analysis, and it is really good for when you're just trying to learn a library. So you see what's going on at every single step. You can also do this with a debugger, but the problem with the debugger is that you can't go back into a segment that you've already run. The benefit of this is that if I run, say, this segment up here, run segment 2, but then I need to update what would happen in segment 1, say if I want to add a new library such as import turtle as all, I'm allowed to go back, stop it, and rerun it, and then I'll update the code below it. Kenta, hello! Which is very useful when you're doing data analysis and you need to update a variable that can change your outcome. Python has a lot of libraries. As seen here, a few are demonstrated. Some that are very important to us here at the Data Science Club is the Pandas library, the NumPy library, the SciPy library, and the Matplot library. You can import libraries in many different ways. You can import it as its own standalone, such as NumPy Pandas. This would just be a duplicate of what's already there, which is NumPy Pandas as PD. The as keyword will tell the Python interpreter that you want to call pandas as a different name. When you have a very long library, such as matplot.pyplot, you don't necessarily want to call that entire string every single time, so you can rename it as PLT. Much simpler, much easier to run, and much easier to type out. Another thing you can do is if you don't want to call the library at all, but you only want to call the methods, you can do this from pandas, import all. The asterisk indicates that you want to import probably help if you spell correctly. The asterisk indicate that you want to, go away, thank you. The asterisks indicate that you want to import every single function, every single method that's inside that Python library. If you only want to import, say, a single function or a single method, Kenta, give me a method in pandas.
Method in pandas?
Yeah. Come on, you can do this.
Random one?
Yeah, any one.
And let's import,
Too slow.
Slow.
We're gone. Okay, I'm going to use a library I'm more familiar with. We can just say import from turtle or from turtle import up. And so now every time there we go. Every time we call up, it's going to know that we want to use the function up from turtle, which is very useful if you only want to use one function in, say, a data analysis library, or in this case, turtle, which is a graphics library. It tells you only want to draw that one frame in that one function, or you only want the function that draws a single frame. You can just use up, and so every time you call up, it'll just do that. Or it'll just call it as you normally would. Say you call print, which isn't something I talked about yet. In most languages, you have something called the system out or the console out command. In Python, we have a very, very, very simple, very, very user-friendly console out called print. You don't have to put a whole class and a system out and the entire library of strings to just call your function out. Just type print, hello world, and yes, hello has a W, and you're simple as that.
You misspelled hello.
I did, but I said hello does have a W now. Okay. Let's see. Okay, so now I'm going to show you how you can install Python natively on your machine. As some of you have seen already, I have been going to the Python documentation. As I said, very well documented, like extraordinarily well documented. Like this is an entire textbook. This is a month's reading of documentation. It's lovely. I love it. Anyway, so we're going to go down to, no, not you. Actually, no, this is actually a pretty cool website. So python.com, which you can see on screen. This allows you to visually see the stack of your Python code, and it will go through and animate your code so long as it's under 1,000 lines. And it's really useful if you're new to Python. Definitely check that out. It is pythontutor.com. Either way, download Python. From Python, the download page, download your appropriate operating system, executable, and run it. In the installation, actually, I might as well just run it now. I have a new version anyways. Maybe take it a minute. I highly advise adding Python to your path directory. And if you're on Windows, Windows had a very, very smart engineer decide that the Explore path limit will be limited to 255 characters. Whoever the genius thought that 255 characters was enough for any path limit, I hope is not at Windows anymore. Python gives you the option to get around this by giving you an option to tell the Windows registry to admit any file path for as long as it wants. And I highly advise adding that to the installation. Just when you're going through installation, just read what it's giving you. Again, definitely click on it. It's going to help your file folder structure. It's going to make life so much better. When you install Python, you're going to see a few things here. Obviously, the documentation. We have our idle, which is the IDE for Python. We have our launcher, which launches Python code, runs it, and a few other things. Over here, I'm using the idle. Idle is really good for testing out functions that you're not familiar with, or just in general doing small segments of code that you can want to debug later. Such as right here where I was showing you how the beginning, the segment function works with the beginning, end, and step. It's very useful in case you forget this, or if you're trying to make sure a function runs the first time, by running the function here in the idle before running it in your code. That's how I use it. It's very useful. You can also do basic math in here. So if you need a quick calculator, this is the way to do it. All right, next thing we're going to go over is functions. To define a function in Python, you type in def, put your name of your function. I'm going to call it func. You can give it 1, or you can give it 0, or any amount of arguments you want. Personally, I like to put an integer because why not? We're going to put integer a. We're going to tell the IDE what variable it's expecting in a. Note that I said earlier, any value can be whatever value you want. And this int that I put right here is only cosmetic. It does nothing but tell your IDE what it expects a to be when someone is calling that function. I'm also going to tell the IDE what I expect to return. In this case, I'm going to return none. None by default is what all functions return unless you return a different variable type. We're going to take a, we're going to multiply it by 3, we're going to print it out and do nothing with it. Now, if you're writing out a lot of functions and you don't want to write out the definition of the function, so if you want to write out skeleton code, the keyword that you're going to want to use is pass. Pass allows the IDE to know that there's supposed to be code there, but you're not going to write it yet. And so this helps when, again, you're writing skeletal code and you don't want to add anything to the function. This will effectively tell the IDE, yes, I know this function is empty. Please stop giving me compiler errors and compiler warnings. Very useful. It is very useful in debugging. Just remember pass. It is muy bueno. All right, let's go over loops next. There are 2 types of loops in Python. There's for loops and while loops. Python does not have do while loops, which is very unfortunate, but a do while loop is just a while loop, but with an if statement in front. So if you don't know how to convert that, there are examples online. The for loop in Python is a bit different than other languages. For takes an iterator as an argument and runs the iterator through the language, or through the function scope, or well, the for loop scope, rather. An example for this, let's take our apple again. We're going to give for our for loop variable called c. We're going to tell it that it's supposed to be a string, and then we're going to say an a. That's right, that doesn't work anymore. So what does this mean? It means that for each letter in A, C is going to have a copy of that value. This is very useful if you're iterating through a iterator, such as a string. So in this case, we're going to have it print out C times 2. The ending value is nothing. And that's just going to print out apples. Notice something I did here is that I multiplied the character value. In Python, we can, later fits, we can take a string and we can have it duplicate itself by using the multiplication operation. This allows us to do funky things like multiplying apples multiple times. Notice another thing that I did here is that I have a keyword in print. In Python, you don't actually have to call or you don't have to give functions inputs in order. You can give it in any order you want, so long as the input value is called and you give it an assignment operator. In this case, I gave the end input a null string, and so at the end of print, it did not create a new line. This is very useful for functions where it has multiple inputs, but you only want to get a few, such as sorting algorithms. The sort in Python has many arguments that you can add. It's very customizable, but most people are only going to use the iterator and the key value, and the key value just tells how to go up and down on the, or which values is higher and which values are lower. While loop, fairly simple. You have your beginning argument, you have your while operator, you have your condition, I less than 100. Always remember to put the incrementer. Simple as that. Very simple way to use it. All right. So the last thing I have on here is we're just going to go over. Oh wait, I completely forgot classes. So Python, of course, is an object-oriented language. So that means we have polymorphism, where you have your parent and your child class, and the child can inherit from the parent. I'm not going to go too deep into polymorphism. It's a whole topic in its own. A very fun topic, especially when you're dealing with languages like Java, where you have to guess, what did the child inherit? What did the child not? Where is the child inheriting from? What is going on? Python is pretty straightforward. You have to tell it exactly where it's going to inherit from. Notice that the child is inheriting from the parent because we tell it in its function argument that that's what we're going to do. Very nice. Something a bit funky with Python, though, is that everything is public. There are ways to make your methods and variables private by using overrides. I'm not going to go over overrides right now, but you import the overrides library, and then you say override, and that tells the Python interpreter that the function below the override is meant to be overridden. Overriding means different variables can be inputted and different functions would be called as a very simple way. In Python, by documentation, if you want something to be hidden, you add an underscore to the front of it. And anyone who's calling the function and sees the underscore should not call it. So if there's an underscore in the method or the function, don't touch it. Well, at the front anyways. If it's in the middle, fair game. By documentation, Python is a camel case language, so if you don't like camel case, it's up to you. Another funky thing about Python is that it allows you to create variables in functions itself that are part of the class. So if I type self apple equals James, create a new function. Self indicates that this indicates, come on. Self indicates that it is part of the class itself. Pretty self-explanatory. Every function in a class must start with the argument self because the function is calling itself in order to work with itself. If that makes any sense to you, good job. Any value, or any variable rather, in the class that is given self can be accessed anywhere else inside the class. This is very nice. It is very useful if you're writing a very long class and then you remember, oh wait, I'm going to need this variable in other functions. Self dot whatever that variable is, now you can call in any other function that's inside the class itself. It's very, very nice. Python also has a lot of documentation for built-in variables. If you add built-in functions such as string, which I'm going to show here. Okay, well I didn't, oh there you go, object string. Object is the name for the classes. Every time you call the string function, it's going to go to the underscore string underscore self, and it's going to pass back whatever is in that function. Very useful if you're using the built-in functions of Python. Very nice for everything else. Okay. Went over that. Right, and the last thing I'm going to talk about is what libraries we use here at the Data Science Club and why. So we mostly use, as stated before, NumPy, SciPy, and Matplotlib. The reason for this is that if we didn't use these libraries, we'd have to use the default libraries of Python. Python inherently is actually kind of slow. The reason for this, as mentioned before, is that it allows you to do a lot of dumb things and allows you to get away with a lot of dumb things. In order to do this, it has a lot of overhead. And NumPy and SciPy get rid of a lot of that overhead and allows Python to run extraordinarily fast. This helps when you're handling very large data sets. So you can analyze tons of data in a very short amount of time. Not to mention, NumPy allows you to do multiple layered arrays. You can do that in Python, technically, but not as easily as if you're using NumPy. Again, for anyone who's used to MATLAB, NumPy basically is Python's version of MATLAB. It can do lots of engineering and mathematical work at a very high level, and it's very useful for us here at the Data Science Club. SciPy gives you a ton of scientific notation, scientific variables, constants, things like that. And Matplotlib is useful for when we want to do math plots, which when you're doing data analysis is very, very useful. Anything to add to that, Kenta?
Thank you. Got pretty much everything.
All right, dope. All right, and at this point in time, I'm going to open it up to anyone who has any questions about Python, Python types, Python concepts, or just coding concepts in general. I know a few people are here for recursion, and so I will go over that right now. Now, if you're in computer science, you should probably know how to recurse. Unfortunately, that's not taught very well here, apparently, so this is a rudimentary course on it. Let me pull up Notion real quick, because I have a very good Notion file on this, and I would love people to read it. That's not it. Oh yeah, while I'm at it. Boop, boop. Not that one, not that one, that one. There we go. If you're new to data science, which a lot of people here seem to be recurring members, feel free to join. It's free, currently. It is free until otherwise notified. All right, so let's bring up recursion. Oh, I love Notion. It is a cult-like application, I will say that much. So we're going to take the function doubled. What doubled does is it takes in a list and then it's going to double the items in it. Now you could easily do this by doing a for loop and then taking the item, deleting it, and then appending it twice. Pretty simple. In fact, we almost did that actually. But let's challenge ourselves and try to use recursion. Here are a few other ways to do this doubled function. I will share this with anyone who's interested. Again, I spent a lot of time in this document, and I really enjoy people to learn recursion from it. So we're going to start out by creating our list. ls is going to have the numbers 1, 2, and 3. We're going to pass it into doubled, and then have it print out 2, 4, 6, which actually I called the wrong function. Doubled does not double the variables. It multiplies the variable by 2. So I know exactly what my pages read. I 100% prepared for this. That should be not obvious. As we iterate, every single time we call the double function, it is going to remove an element and it's going to store it in temp. So if you look here, if ls is going to check if the list has variables. The list type, if it has no variables in it, it's going to return none. None, if passed through a Boolean statement, will return false. So this is just a fancy way of using Python's really fun mechanics to make code look very simple. The cool thing about recursion is that it's always loaded into the stack. So we're going to use the stack and manipulate it in a way to load and unload our function. That's what I like to call it. Notice down here, I have implemented a pseudo stack. It tells you what position of the stack each item is. This is assuming that the system is little endian. That means it's going to start from the bottom and work its way to the top. Right? Yeah, I'm just going to say that. If I'm wrong, have fun with that. It's either it starts from 0 and goes to 255, or it starts at 255 and works down to 0. Either way. Every time that we call doubled, so our first attempt, we went through here, we popped it, so temp, this version of temp now has our last, is that our last or first? Our last. Well, what?
Probably different.
Yeah, because it's in lists, Python lists are actually stacks.
Oh.
Yeah, so it's going to pop from the top, which is going to be the end of the list, so 3. So this temp is going to get 3. We're going to call double again. This list is going to have only 2 variables now. Note that the list here and the list here are exactly the same. So currently this list only has 2 variables. It's going to pop again. We have now a new variable temp in the stack, and it's going to hold 2. Note that list at this point now has only 1 variable, which is 1. All the lists here are exactly the same, except for this one, which is constant. Which in hindsight, I probably should have added another list to the variables on the stack, but whatever. Now, doubled is going to be called again. Notice how doubled is still in place. Every single call, the function is still active. It never exited scope. So according to the stack, it's still there. And so that's why I visually kept it like this. Again, we're going to have temp load in there. It's going to call double one more time. Notice at this point, the stack is, our list has no items. Our stack is full of temp values that are full of the variables that were in that list. And so we're going to call doubled one last time. Notice that's 1, 2, 3, 4 doubles called. And at this point, list has nothing in it. So it's going to skip this if statement and return to our none value. So that means we're done with this scope, and we're going to go up the stack. So notice the stack here is the same as the stack before. At this point, this temp variable, again, was 1. So we're going to take it and we're going to add it to itself, effectively multiplying it by 2, because that's how math works. we are going to add it back to the list, and we're going to exit the if statement and go into the return value, which is none. At this point,